Hello everyone, my name is Todd. I'm going to be your logic tutor. And we're continuing on with doing natural deduction using the rules of proper inference. Okay, now this problem looks a little bit strange. We have to prove F and not F. Okay, we don't see not F and F anywhere together, or its opposite or anything like that. So what we're going to need to do is get not F and get F, and then just conjoin them. Okay. We could get an F from 4, but it would require a not F, so we probably should worry about getting a not F first, and then go get our F. I'm going to get a not F from line 1. I'm going to do a modus tollens to get a not F. But what that requires is that I get the opposite of that giant consequent. G or H and P if and only if Q. Okay. Well, let's get them one step at a time. Look at 2 and 3. If you look at 2 and 3, it gives me G or H 2-3 disjunctive syllogism. So that's the first part of that consequent, and the P then Q is already on line 3, so let's just put 3 and 5 together. I get G or H and P if and only if Q, and that comes from 3 and 5 conjunction. I just put those lines together. And line 6 is the opposite of the consequent on 1, so I get not F, 1 and 6, modus tollens. All right, so I've got my not F, and look at line 4. Strange, but it says if you have a not F, then you get an F. So because I have a not F, I have an F. So that's from 4 and 7. Modus ponens, and now I just put those two creatures together, not F and F, 7 and 8 conjunction, and we're done. So let's move to the next. 65 here. Let's prove this big blob here. Now, I don't see anything approximating that blob or its opposite in an antecedent, and I notice, however, though, that all the operators are conjunctions, so if I can go get all the parts, M, N, and O, separately, I can just put them together using conjunction. So, let me see. Not sure which one is the easiest to go for first. And let me go after the M first, which I can get from line 3, but that requires the opposite of that consequent H and not P. All right, I have the H on line 4, so I need the not P, which I can get from 1 and 4, not P, 1, 4, modus ponens. Now let me put that H and not P together, H and not P, from 4 and 6, conjunction. Now, this, line 7, is the opposite of the consequent on 3, and that allows me to do a modus tollens to get M, 3 and 7, modus tollens. All right, so I have one of my pieces, the M. What about the N? We'll look at line 2. It says not M or N, and I have an M, so I can do a disjunctive syllogism and get N. 2 and 8 ds. So I just need that O, which is on line 5 if I have a not P, and look what's right below it. So I can get O, that's an O, I was going to make it a Q, from 5 and 6 by modus ponens. Now all I have to do is start putting them together. So M and N from 8 and 9, conjunction. And then to that, I'm going to add the O. So that's 10 and 11, conjunction. And I'm done. All right. Here we are. We have to prove a giant conditional. I don't see anything that looks like it in the premises or its opposite, so I'm thinking go get P then Q then blank and blank then R, put them together by hypothetical syllogism, and you'll be done. So let me see if I have a P then blank. P then Q then blank. I do right there in line 3. And then do I have a blank then R? I do right here on line 1. So if I have those two pieces, I'm good to go. Problem is, to get the not I then R, I need an I. I can get an I from line, or not I from line 3. If I had a P then Q, which I don't have, but notice 2 and 4 can be put together to make one. P then Q, 2, 4, HS. And then thinking about 3 and 5, I can get not I, 3, 5, modus ponens. And with that I can get not I, then R from 1 and 6, modus ponens. Now I have the two pieces I said I needed. Look at 3 and 7, and I can put them together. I have P, then Q, then R from 3 and 7, HS,